Hi everybody, we're doing well. This is day 5 of our homeschool adventure. Today we are going to start talking about sedimentary rock. Again, I wanted to talk about the fact that this is going to be a lesson that'll take place over a couple of days because there's an awful lot to learn about sedimentary rock because we learned so much about the history of the earth based on sedimentary rock. So the first thing I want to do is talk about the fact that only about 5% of the Earth's crust is actually comprised of sedimentary rock. Having said that, most of the rock that you actually see and interact with on a daily basis is actually sedimentary rock. Sedimentary rock is spread as a thin, discontinuous layer and basically covers 75% of all the continental crust that we see. The most characteristic feature of sedimentary rock is that it is built up of a layer of materials over thousands and millions of years. When this visible strata has a layered appearance, there is usually a clear demarcation from one layer to the next, with the younger layer always being on top. And this is actually called the law of superposition. So the older rock layers are well below the newer rock layers. There are a number of things that we're going to talk about in terms of how thick those layers are, what the conditions are that affect all of that. And it's because geologically, it is how we are able to analyze a lot of what has happened in terms of how the earth has evolved. So first of all, we're going to talk about what exactly sediment is. It's unconsolidated rock particles, and sediment is actually created by the weathering and erosion processes, and it's the weathering and erosion processes of existing rock. And again, I'm sorry, I've got my notes off to the side here, so if I'm looking off to the side, I'm actually just trying to make sure that I'm on track and I'm not missing any of the information. There's quite a lot to go through today. We are going to do a big overview and then go back and look at different parts of it separately. So again, sedimentary rock provides us with a history of the past. The chemical composition of sedimentary rock reveals past environmental history of the earth. And this environmental history includes volcanic ash. It includes, we're able to track levels of precipitation, temperature. So if we've got a lot of sediment that contains a lot of matter, a lot of plant matter that's typically grown during a time of a lot of rain and heat versus a time of glaciation where we're going to see less plant matter. Because sedimentary rock is formed at the surface of the earth, they also contain fossils. And I want to go back again and talk about earlier in the year, we studied continental drift, and we know that index fossils were a key piece of the evidence that proved Wegener's theory that continents drift. We find these index fossils in sedimentary rock. So it's important that we are able to track the evolution of species through time as well. So sedimentary rock also gives us a really good look at life on Earth, not just the life of the Earth. So that's important to keep in mind. So when we're studying the theory of continental drift, we were looking at this critical piece of fossils. I did tell you, for example, that we can find trilobite fossils on top of Mount Everest. That means that at some point in time, trilobites lived in warm, shallow seas. So at one point in time, Mount Everest had to be sea level. That's the only way there could be fossils of trilobites on top of Mount Everest. It had to have risen up as part of mountain building, which comes from the pushing together of continents. I believe that Everest is a fold rather than a fault mountain. So it would be a coming together and a crumpling up of two plates pushing together. So when we're studying all of this, we need to understand that there is an actual process that takes place for sedimentary rock to form. It is a long process. It's not something that happens over a short period of time. And it's something that occurs in 4 different stages. Those stages are weathering, erosion, deposition, and sedimentation. Weathering is the process of the disintegration or the decomposition of rock that's at or near the Earth's surface. Wind, water, ice, and reactive chemicals weather rock. The rocks break apart into smaller and smaller pieces. There's a rounding and a smoothing of these rocks, and their chemical composition can be transformed. There are two different types of weathering that occurs. These are mechanical and chemical weathering. Mechanical weathering is usually caused by water or glaciation. So I want you to think about what happens, and we're going to talk about this a lot in terms of how canyons are formed, particularly how parts of the Grand Canyon were formed. When glaciers come forward, they are strong, forceful, heavy, and they gouge the earth. When they recede, the same thing happens. They gouge the earth. So that's part of that weathering that will happen as the ice either moves forward or moves back. It's going to work at wearing away and crumbling rock. Same thing happens with regards to snow, sleet, rain, floods. All of that stuff works over time to wear down rock. Chemical weathering, however, is the main cause of sedimentation. So more than mechanical, we have chemical weathering that takes place. Water is also the mechanism by which chemical weathering takes place. When rain falls, it acts as an agent. It reacts with the carbon dioxide in the air and in the soil to produce something called carbonic acid. This makes rain slightly acidic. And as this acidic rain lands on rocks, it begins to dissolve and weaken them. And it begins to wear away and break down the rock. We're going to talk a little bit more about different types of weathering with regards to things like ice wedging and things like that. But right now, these are the two main things that we're going to focus on in terms of how rock breaks down to be worked along that process of sedimentation. Erosion is the next step in this process. And erosion is where weathered particles are removed from the rocks. So the rocks have already been weakened, but now erosion is going to take place and start wearing away at the rock. Weathering has taken place. So it's weakened the rock, and then erosion starts working away and breaks off these particles and removes them from the rocks. These particles are then transported from their original site. They are transported by a number of mechanisms. We've got wind, we've got rain, we've got animals, we've got, again, glaciation. And as part of this erosion, the sediment moves from its original site. Because of gravity, the ultimate direction that sediment erodes is downhill, so down towards the ocean. So all the stuff from the tops of the mountains are going to move down towards the ocean. As the sediment is transported, it continues to weather. So as it's being knocked along its path, it's being smoothed. Rough edges and jagged edges are being bumped off and worn off as it follows along its path. Those then small particles are once again part of that whole sedimentation process. The farther that particles are transported, the smoother and the smaller they're going to get. More and more bits of them get worn away. They become rounder, smoother, and we see this a lot with smaller rocks that are near the sea that have traveled considerable distances. Step 3 for sedimentation is actually deposition. And this is where the sediment drops out of whatever transport mechanism that's carrying it, oftentimes water. The force of the water directly impacts the size of the sediment that it can carry. So typically what happens with water is the farther that it gets from its source, the weaker that it gets. As a result, along its path, the heavier particles drop out early. So it's the smaller particles that get carried farther because that's all that the weak water stream can carry. So typically what we see is this is being deposited in horizontal layers. This is, by the way, again, the law of superposition. So it's being deposited in layers along the way, horizontal layers. It's going to be lying flat. Usually, again, bigger things are gonna drop out earlier. So what we typically will see is larger rocks and boulders at the bottoms of waterfalls. Waterfalls are very forceful movement of water and can take larger things. Gravel is usually deposited around streams and slow-moving rivers. And sand particles are going to travel all the way down to the mouths of rivers. Some of the silt and stuff that builds up at the mouth of a river can have traveled hundreds of miles from its original site. The final step in the process of sedimentation is something that's called lithification. And lithification itself has two steps. Those steps are compaction and then cementation. So a layer of sediment, when we're talking about sediment, we're not talking about loose surface dust. We're not talking about soil that we use for planting crops. We're talking about thick rock layers. And as those rock layers are laid down, each successive layer that's placed on top of it, that pressure works to compact the rock together. So it's pressing it together. And we talked about this as well with metamorphic rock, is that pressure of pushing the rock together makes it more and more of a solid. The other thing that happens is with cementation, as water, this compaction works and water gets squeezed out of the tiny spaces between the sediment particles. And it also mixes with the chemicals that are being washed out. And that chemical solution mixes with the particle to create sort of a binding agent. And just like you would work with water and a binding agent to create the cement for your patios or your driveways, it's a similar process that occurs with rock layers. Now there's typically 3 different types of chemical solution that we're going to get with those rock layers. Probably the most common is silica. The other one is calcium carbonate, and you're going to find a lot of calcium carbonate squeezed out when we have limestone. And limestone is a sedimentary layer that we are going to talk about in more detail. And then the third type is with iron oxide. So these chemical compounds mixed with the water then squeeze in and fill in the pores, and combined with the compaction process of successive layers being built on top of it, we get really solid rock layers. Now, even though sediment is a thick layer of rock, if you walk along a sedimentary layer, it's easier to scrape it off. It's easier to rub it and get it to loosen up than it would be for something like igneous rock or metamorphic rock, because they are literally small particles of minerals and different soils and organic matter that's been pressed together. That is the other thing to talk about with regards to sediment, is it does contain organic matter. So when we talk about the silica, that is the solution that typically though produces the hardest, most durable and resistant layer of sedimentation. What we see a lot of here in Utah and Arizona, for example, Bryce Canyon is an excellent example, as well as some of the layers of the Grand Canyon, are when iron oxide actually mixes it becomes or is produced as the sedimentary agent. And when that happens, it turns the sediment to either an orange or a red color. That is because the iron reacts to oxygen in the atmosphere and changes its color. It essentially rusts. Okay, so it's the same process that turns, rust is the same reason that rust is red. There's an oxidation process that takes place and creates a reddish or an orangish layer of sediment. So that's basically the underlying concepts for sedimentary rock. Again, I want to recap. Our learning objective today is to basically just understand that there's a 4-step process that takes place in order for sedimentary rock to be formed, and that is weathering, erosion, deposition, and lithification. I do want to say, don't worry about the word lithification. It's really, I suppose to give you the correct definition of it, lithification basically means to turn into rock. So the definition of lithification is to turn into rock. So that is basically the last step that takes place to turn rock particles or separate particles into rock, that compaction and cementation process. Weathering is the weakening. Erosion is the breaking away and the transportation. Deposition is getting that to land into a particular place. And lithification is the compacting and cementation of that material into a unified rock layer. The other key concept here is to understand the law of superposition. It's a great big term to basically say that older rock is on the bottom and younger rock is on the top, and really that's just common sense, right? Because you're not going to have young rock on the bottom, are we? It's going to be building up over layers. So the other thing that is really, really important to understand, and we're going to focus on the Grand Canyon. I've got, there's one of the videos on natural phenomenon on Discovery Education for you. And then I have 2 other short videos about the Grand Canyon. I'm going to show you a diagram of the Grand Canyon, and we're going to actually talk about specific layers of the Grand Canyon. There is that white layer, the white ring towards the top of the Grand Canyon, which is coconino sandstone, is basically called the bathtub ring for the Grand Canyon. We're going to talk about what has happened over time in the Grand Canyon and how we can track that. We do know, by the way, and again, we've talked about this when we talked about continental drift, that at several points in time, the Grand Canyon was underwater. It was when we had warm, shallow seas, and 90% of the earth was covered in water. And the reason that we know that is because of the presence of limestone and fossils that we have there. So we're going to talk about the significance of being able to see something like the Grand Canyon in our state, where we can, it's basically like slicing through a layer cake and being able to see the earth in all of its glory over time, which is pretty amazing. There is going to be this will be the last part of talking about rocks that we do. Once we finish with sedimentation, we're then going to study the rock cycle, which is basically pretty short. I know you've already been exposed to the rock cycle in other grades. Before we move on to physical sciences, there will be a small test, not a big test, but a small test on this material. Obviously, you can use your notes, right? All right, so if you have any questions, please email. If you need to rewatch this, if I've spoken too quickly, if I've not explained things in enough detail, I'm pretty new to videotaping myself. So you need to really let me know. I do need your feedback on that, all right? It's been great reading your materials online. I'm really happy to see some of the answers. I'm really happy to see all of you working hard and staying up to date with your studies. It's really important that we do that. And I'll talk to you later. All right, bye.